Welcome to Facing Future. A large portion of the human population lives on or near coastal areas that will be impacted as sea levels rise. That's why what's happening in Antarctica is of crucial importance to us all. Today, Paul Beckwith, a member of Facing Future's team, will tell us what he knows about that critical continent. Paul.
Yes, thank you, Dale. So many people for a long time have considered Antarctica to be a stable continent, with its own sort of weather systems. I mean, there's no connection with land, so the jet streams can completely go around over the oceans, and you can get ocean currents going completely around the continent, and that kind of isolates the continent from the rest of the planet. But that's not really the case. What we're seeing is more and more extreme melting events in Antarctica. We recently saw a heat wave where Antarctica was 70 degrees Celsius warmer than normal. And at the same time, the Arctic was 40 degrees Celsius warmer than normal. And this was an unprecedented simultaneous warming of both poles. So Antarctica is a rapidly changing continent like the rest of the planet is under abrupt climate system change. And I'd like to use the expression, what happens in Antarctica doesn't stay in Antarctica. It's not like Las Vegas. Now, I came up with that expression for the Arctic, but it equally applies to Antarctica.
Indeed, Antarctica is critical to all of us. It's hard to imagine a more serious aspect of climate change than what could happen in Antarctica. Already we've seen the Larsen A and Larsen B ice shelves melt off and break off, and Larsen C is threatening to break off. Now, none of that is on the land mass, so it doesn't affect sea level rise so much.
So the Antarctic Peninsula of Antarctica is probably the fastest warming location of Antarctica because it extends the furthest from the pole. And we thought that these massive ice sheets were quite stable, but there was events where Larsen A over the space of several days just completely collapsed and broke up into ice cubes, basically, which then floated away and melted fairly quickly. And the same thing with Larsen B. And those events have been now attributed by recent research that looks at a phenomena called atmospheric rivers. So these are very long ribbons of the atmosphere. They can extend thousands of kilometers in length, and they're generally a couple hundred kilometers at most in width, and they carry huge amounts of water vapor. And as the jet streams slow down and become wavier and extend further and further to the poles, the ridges, it can carry these atmospheric rivers, this water vapor, up into the Arctic or down into Antarctica, and bringing vast amounts of heat, which is latent heat because it's water vapor. As the water vapor, as it hits colder air, the water vapor condenses into droplets, which will then cause precipitation, either rain or snow, and that heat is released. And that's the heat that's responsible for causing these massive heat waves recently in Antarctica. That's the heat that has brought lots of rain to actually the coast of Antarctica in periodic events. And those events, although they're still fairly infrequent, it might happen a dozen times in Antarctica, there's a huge amount of melt in Antarctica that's associated with those events. So we're understanding the science more. So we've got one thing that's switched in Antarctica is the sea ice around the continent. So we just hit a record low of the sea ice around the continent, and up until about 2005, sea ice was actually increasing in area around Antarctica by about 1.5% per decade, and then it switched after about 2005, and now it's decreasing, and we're setting record lows. And the difference is that the ocean is warmer underneath, so it's melting the sea ice and the ice shells from below, and also the atmosphere is becoming warmer above, especially with these atmospheric river events. So it's melting the ice from above, and those things combined have been really greatly reducing the Antarctic sea ice. Now, of course, sea ice doesn't cause sea level rise.
Well,
Right.
it's when it melts off of the land mass, which has been, if it's been on the, it's been floating on the water, we don't have to
Yes.
worry about so much.
Yes.
But when it takes away the stuff
Yes.
that's on the land,
Yes.
that's when it
Yes.
really is a problem.
Yes. So the sea ice is formed from freezing seawater. So sea ice is typically only, up to about 5 meters thick, and it can get ridged up into thicker regions of ridges that are thicker. But the big concern is that the ice shells, which is the ice that is attached to the ice sheets that are on the land, right? They're kind of on the land and they're flowing down to the coastlines, and where they extend over the water on all the coastlines, those are the ice shells. And the ice shells are thinning on the underneath because of the very, very warm ocean water. And they're melting on the top from the warmer temperatures. And these, when we get these atmospheric rivers and actually rain on the coastal regions, we get, and melting, very warm temperatures, we get melting and melt ponds on the top of the ice. And then there's a process called hydrofracturing, where those melt ponds kind of drill their way through the ice and cause what's called moulins, big holes in the ice that can go right down to the bedrock or right through to the bottom of the ice if it's an ice shelf. And those can, if there's enough of those, it's like Swiss cheese on the ice, and then the ice can completely fracture and break, like Larsen A or Larsen B. And we've had some of these events, warming events on Larsen C recently. So I think it's just a matter of time before we get another massive ice shelf collapse.
Now, the Larsen shelves, they are like a peninsula off the coast of Antarctica to the north. If we lost all of them, would still Antarctica be intact? Is that as
okay?
critical?
So as far as, now you were talking about sea level at the beginning. So the problem with the ice shells, where they're attached to the ice on the land, that will cause some sea level rise because that ice is kind of held in place. But where they extend over the ocean, they're floating. So 90% of that ice is underneath the water, 10% is above. And at the calving edge, at the very edge, if you take a ship right up to the edge of the ice, you can have 300-foot or 100-meter high ice cliffs. And you see 100 meters above the water, that means that's only 10%. There's 900 meters going down underneath. So there's a massive amount of water in those, but those are essentially floating. But the problem is when they go, it's like taking a cork out of a wine bottle. The flow rates of the glaciers on land greatly increase, and then that's what gives you the potential for massive sea level rise.
Okay, so it's normal for some calving to occur every summer in Antarctica. That's not unusual. But the rate of calving is greater now than it has been. And do those ever freeze in the winters there?
Okay, so the ice shells, what would happen if you get a massive ice shelf breakup is the glacier on land speeds up and tries to create a new ice shelf. But that's a process that takes a long period of time. So usually what happens is the calving front has just moved very much further inland. Now, what you have to remember, it's very interesting to look at a map of Antarctica without any sea ice on it. Look at the topography of it, and what you see is that West Antarctica is basically, there's some areas above water, the land, but a lot of it is under the water. So a lot of those glaciers in West Antarctica are, they're sitting on bedrock that can be several, a mile, mile and a half, several miles deep. Okay, so that ice is grounded. The ice is so thick that it's pushing down and it's sitting on the bedrock that is well below sea level. So you can see the problem, because most of the loss of mass of Antarctica is from the warming oceans by far. The warm seawater gets underneath and melts it from below, because the temperatures, are generally very, very cold on the surface of the ice sheet. So if if it's normally minus 60 Celsius, and you get a warming of 40 Celsius, well, now you're at minus 20 Celsius. You're still not above the melting point of the ice, melting temperature of the ice. So the warming doesn't cause surface, you're not getting a lot of surface melting from temperature. You still have the very strong sun hitting the ice, and the ice as the ice melts back, there's a lot of impurities in the ice, and those things like black carbon, ash from wildfires, et cetera, they've accumulated. Whatever's accumulated in the ice over many, many years gets exposed at the surface. We're also getting different types of algae that are at the surface, different biological life, which is dark. So all of those things reduce the reflectivity of that ice, cause more absorption of sunlight in the summers, and cause more melting.
Right. Now, that's a big concern as well, because we're not sure what is buried in that ice. Could be viruses of some kind. That is a concern I've heard.
Yes, that's actually a concern more for the Arctic, because what we're talking about Antarctica, but all of these processes are applicable to Greenland. And it's concerned that there could be some airborne viruses, et cetera, that were from pre-plagues back in history, that some got in the air, some were transported there, deposited trapped in the ice, buried over time as the snow accumulates and then becomes ice. So the layers are looking back through time, and as these layers melt off, you could expose the ice that was created by snow compacting from a period of time when there was a global virus, a global pandemic or something from, Black Plague or some other virus. And if you reach down to that level, maybe there's a virus that's dormant, that's sitting in there that could be exposed. So that's
as far as we know, then Antarctica has never been inhabited. Is that correct?
Yeah, it's quite different from the Arctic, because we know there's been periods of time when the Arctic has been completely ice free, right? There can stumps of wood, of old forests and so on have been found on Greenland. Long ago, a period of time when the Earth was much warmer and there was no, a very, very warm Arctic. Now, at that time period, there's a lot of theories as to what Antarctica was like.
It's the world's most remote and isolated continent. It's home to glaciers, mountains, plants, and penguins. But today, Antarctica is noteworthy for what it doesn't have. In modern Antarctica, there aren't any trees or native terrestrial mammals, reptiles, or amphibians at all. But it wasn't always like this. Thanks to plate tectonics, Antarctica has been connected to lots of other continents at various points in deep time. As a matter of fact, before the start of the Eocene epoch about 56 million years ago, Antarctica was still joined to both Australia and South America. And the fossil record tells us that in the early Eocene, Antarctica was a warm, forested place, very different from the continent we know today.
But I suspect that At least the boundaries of Antarctica, I'm sure, had a similar situation. If you go inland in Antarctica to the higher elevation regions, then it's more of a scientific question as to what happened. But see, there were other things going on because what happened is that Antarctica wasn't always isolated from all other land masses, right? There was time, remember continental drift occurs. We're talking about hundreds of millions of years.
Pangea.
Yeah, there was actually a connection, a land bridge connecting Antarctica to South America. Okay, so that would have meant that Antarctica was quite a bit warmer than it is now, because it didn't have that isolation effect with the water being able to circumvent the whole continent. And in the northern hemisphere, the Isthmus of Panama, of course, it's closed off now. There was a period of time when that was open. There was a connection there between the Pacific and the Atlantic. So when there's geological changes in different, a different arrangement of continents, that has, of course, a huge effect on whether ice will form or not on a particular polar region.
Okay, you mentioned it raining in Antarctica. Is that a normal process? Does that happen at other times, or is this something new?
Yeah, it has happened at other times, but extremely infrequently. And with these atmospheric rivers becoming more powerful and happening more often, they're actually longer, they're extending more poleward than they used to, and they're carrying a lot more water vapor than they used to. Those are bringing these, they're bringing, it happens very quickly. So, you get the atmospheric river extending, there may be a blocking, so air coming towards it can't go through it because it kind of is blocked, and it has to deflect over to Antarctica. And this is happening more often, these blocking events. And what can happen is the temperature can skyrocket over a matter of a day, and stay really high for 3 or 4 days, and huge amounts of water vapor are deposited as rain on the coastal ice sheets, the ice shelves, the ice sheets, the sea ice, and create all these melt ponds on top of, say, Larsen A or B, and cause a complete breakup of the shelf. So the study, a study that categorized and tried to parameterize what actually was happening with an atmospheric river event, it found that when there were these atmospheric rivers, that was when the major melting events have been occurring, both in the Antarctica, East Antarctica, West Antarctica, also Greenland. I mean, we're finding this more and more. And these atmospheric rivers, as we know, they affect California quite often, bringing very, very heavy rains, causing landslides, washing out roads. They moved up to British Columbia in last fall, and they've actually been responsible for some of the extreme weather events that lead to tornado swarms across the southern U.S. So we're learning a lot more about these, and probably most people never even heard of these things until last year, I think, probably.
Yeah, it's a very frightening phenomena, the atmospheric river. I know you were following the one in British Columbia. So we're all very interested to know what's going to happen in Antarctica. And we thank you, Paul, for giving us more wisdom about it today. And maybe next time we'll explore the atmospheric rivers.
Yes, thank you for having me. And, like I said, we used to consider Antarctica as a sort of a stable place, especially East Antarctica. And as we get more and more of these incursions of huge warmth and moisture from this phenomena, we can't consider that. And it's not you know, it basically, we need a rewriting of all the climate models, because with these atmospheric river phenomena, global sea level rise is going to be far, far higher than any of the models or people are saying. It's going to be, much, 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 much worse. And this is a mechanism which will do that.
Mhm. Well, we none of us really know what's going to happen, but we know it's going to be very serious as we continue business as usual. And we know that many coastal cities will be flooded no matter what we do at this point, which is very sad. But thank you, Paul.
Well, thank you.
Okay.